Hello, Management 560 students. This is Professor Robinson. I will be working through some of the questions from our homework 2. So first I'll start with a demonstration of a one sample z-test of a proportion, and then we'll move to 2 independent samples, and then from there progress to a more than 2 and doing a chi-square. So to practice these kinds of questions, I have here a data set entitled Effective Difference Sense on Time to Complete a Maze. So this was an experiment where people wore a mask, and that was, I guess, made to smell a certain way. And then depending on the smell or not, they had to complete this maze, and the question is whether the smells would affect how quickly they did the maze. So I don't know the answer to that question, but we've got some data here, or we could find out. And just as I'm looking at this, it looks like roughly half of the participants were smokers. But that's a theory that could possibly be rejected, right? So this is just I don't know statistically that that's true. I just look and I'm guessing maybe it's half, but we can find out if indeed it's possible that it really was half, or if we can't know for sure. So I'm going to take my smoker column here and copy it. So I've got my 21 individuals that smoke, and I'm going to go to the bivariate analysis on proportions Excel sheet. So this will be up on Blackboard. This is the one we were using in class on Wednesday. And we've just got a couple different things. We've got our z-score, our p-value. Right now it comes built in with a test that half of the observations, or that 20% of these observations are male, which is a theory we reject. Is there half? So I'm just going to do this one sample z score. We're testing the proportion of one variable against a theory. So my theory was that half the people in this testing group were smokers, and it turns out the actual proportion, we'll see, we want to do yes, are smokers. Yes. So we have 8 smokers out of 21. So the actual proportion was 38%. So clearly not half, but maybe the goal was to get to half, and they didn't quite make it. And so the question is, did they not get there because of randomness, or because they really were, the theory really was something else? So using the 21 observations we've got in our calculator, we get a z of negative 1.091. So the reason it's negative is because the actual proportion was under our hypothesis, and then the z-test that gets you a negative sign. So we've got this z-score that is essentially small. It's not bigger than 2 or more negative than negative 2. And that's borne out by the p-value here. So we've got a 14% chance that this difference, that it was 38% and not 50%, that difference was due to randomness and not actually deliberately collecting fewer smokers, or the actual proportion of smokers in the population not being 50%. So this we would say, therefore, because this p-value is not below 0.05, right, it's above 0.05, at the 95% level, we could not reject the null hypothesis. And in this case, we gave it a null hypothesis. The null was that it was 0.5. So we do not have enough evidence in this data set to reject 0.5 as a theory. So that is our example of a one sample t, and we would type then the question would be, is the fraction of smokers in the sample 50%? And we would say, in English, yes, or at least we don't have enough evidence to say it's not 1/2. And that would also mean that you would type a 0 on your homework. Now, if I asked if the proportion was, say, 80%, now we have a z up at 4.8, and yes, we can reject that theory. We know that the proportion of smokers in the data set, in the population that it was sampled from, is smaller than 80%. We do know that. That's a claim we could make. So now that we've done this one sample z-test as kind of a warm-up, let's move on to comparing two samples. And so one thing you might want to think about trying to do is we've got these, we've got smokers and non-smokers, and then we've got these opinions, positive, negative, and indifferent. And this is whether the participants in the study felt whether or not they thought the smell was a nice smell or a not nice smell, a negative smell. And so I'm curious to think whether the proportion of people who like the smell are different between smokers and non-smokers. So I'm just going to clean up this data set in here, get a little space. So the first thing we are going to want to do is sort. I'm going to sort all the data set. I'm going to sort by smoker. Data sort by smoker. So there we go. So now we've got our no smokers and our yes smokers. I'm going to copy this. So here's our non-smoking group. And I'll go back over here. This is a z-test for the difference in proportions. So these are non-smokers. And I will paste the, oops, we got a copy again. And we paste values. There we've got some of those. And now let's look up smokers. So these are smokers here. This. We don't want any leftover data. Okay, so we've got more non-smokers than we have smokers, and they we have these three categories: positive, negative, and indifferent. And we were wondering whether more non-smokers or whether more smokers liked the smell, felt it was positive. So if we type positive in here, now we're counting up the category. So notice there's 4 smokers who like the smell, and 1, 2, 3, 4, 5, 6 non-smokers who did, and that's being reflected over here. So now we've got the actual counts, and 4 is exactly half of 8, and 6 is slightly less than 13. So we've got our proportions, 46% and 50%, and that's not a big difference, especially for this small data set. But we'll diligently do our duty and calculate our z-score using this calculator, and we get a negative 0.017. So this is a very small z, and that's going to be reflected in the p-value. So we've got a p-value of 0.86, which is much, much larger than 0.05. So in English, we would say that it doesn't seem to be the case that smokers and non-smokers perceive the smell differently, at least in terms of positive. And if we want to just check really quick, we could see if there's a difference in the negative values. And it does seem like smokers have, it's 25% didn't like the smell versus almost 40% for the non-smokers. What you'd be tempted to think is a meaningful difference, but at our sample size, it's not. So our z is bigger, but clearly not big enough to make any sort of statistical claim about the reality of this difference. In fact, it's just as easily a chance of randomness as it is not. And so if the question were to ask, is the positive smell, does the perception of the smell as positive, is that independent of smoking? And we would say yes. The difference, there is no statistically significant difference between the groups, and so they are independent, and that means in your homework you would type 0. So that's the one sample. That's a z-test of proportion against the hypothesis, and then the z-test of differing proportions. So in the next video, I will do an example of a chi-square test in SPSS, and then an example of a chi-square test in Excel.